Algebra 1, Section 3.4. We're continuing our talk about linear functions. A good example of a linear function is something called an arithmetic sequence. So this is just a set of words that you know what these words probably mean individually, but you probably haven't seen this put together before. Arithmetic sequence is just a sequence, a set of numbers, and every number progresses by the same amount or the same rate every time. So if I look at this, a row of dancers. So row 1 has 1 person. Row 2 has 3 people. Row 3 has 5 people. Okay, so if I look at this, on row number 1, we have 1 dancer. Okay, and so if I'm counting rows, let n equal the row number. Okay, then this is row 1. Okay, and then a of 1 is the number of dancers on row 1, which is 1. In row number 2, I see 3 dancers. So this is n is equal to 2. So a of 2, how many dancers are in row 2? That is 3. If you go to 3, row 3, there are 1, 2, 3, 4, 5 dancers. So a of 3 is 5. And then if you go to rows 4 and 5, so on row 4, we've got 7 and then 9. Wait. Yep, so I have 7 dancers and 9 dancers. So A of 4 is 7, A of 5 is 9. Okay, so if I were to keep going, what this sequence is just the sequence of numbers. So this is an arithmetic sequence of 1, 3, 5, 7, 9. That's what I mean by an arithmetic sequence. So that is the sequence that I'm looking at in this particular case. So give the function a of n. Well, let's look at this. What is the slope? So 3 minus 1 is 2 over 2 minus 1. So that it goes up 1 every time. 5 minus 3 is 2. 5 minus 7 is 2. 7 minus 9 is 2. So before I introduce the term arithmetic sequence, you're used to thinking of y equals mx plus b. You can look at this data and tell me that m is 2, okay? So if I look at this, the slope is 2, because every time the row number goes up by 1, the number of dancers increases by 2. So this function a of n is going to be equal to 2n plus some number b, okay? It goes up by 2 every time. So now I can just pick one of those points. A of 1 is 1. So that means that when you plug in a 1, you get a 1, okay? So this means that b is going to be equal to negative 1. So this function, a of n, is 2n minus 1. So you can check it. If here n is 2, 2 times 2 minus 1 is 3. That's what I get there. And the next one, 2 times 3 minus 1 is 5. There's my 5, okay? So this is my function. So this arithmetic sequence of numbers really is, the same thing as y equal mx plus b, is a linear function. So this scenario represents a sequence. A sequence is a list of numbers that often forms a pattern. Each number is a term of the sequence. In an arithmetic sequence, the terms have a common difference, or they're equidistant. It means that if it was a line, it had the same slope. It means that every time I go up by 1, like on those dancers, every time the row goes up by 1, I add 2 more dancers, okay? So how are sequences related to functions, okay? It's very similar, because if I look at this, the function that we had, when we look at a line, has a slope, and that slope means that it's the same slope all throughout the line. So it's very similar that in a sequence, even though you're not drawing a line, you're saying each time the sequence progresses, I'm going up by the same amount. So it's related in the sense that, linear function has a common slope. And then what we're seeing here is an arithmetic sequence has a common difference. Okay, just a little bit terminology that's different, but it means that as the number of dancers goes up, it goes up by 1 every time. So if you look at this, the number of rows that I had in that previous example, 1, 2, 3, 4, and 5, okay? And then if you look at A of 1, I had 1 dancer on the first row. A of 2, I had 3 dancers on the next row. A of 3, I had 5 dancers. A of 4, I had 7. And then A of 5, I had 9. Okay. Now, rather than using this function notation, we like to be sort of more poetic and get a little bit more concise. We use a subscript. A1, the first number in that sequence, was 1. A2, the second value in that sequence, was 3. A3, 5. A4, 7. A5 equals 9. Okay, so instead of using parentheses, A substitute a 1 in, we're just saying A1, the first element in the sequence, A2, the second element. So we're just using the subscripts for a little bit shorthand notation. Okay, so we're using that. So if I look at this function A of n, we said that A of n is what, 2n minus 1. So we're just going to use a subscript, an is equal to 2n minus 1. So if I wanted to find out how many people were in the 9th row, then I would just use this formula. A9 is going to be 2 times 9 minus 1, which is 17. Now, suppose that I knew how many people were on the 99th row, okay, without figuring it out. So if I know how many people are on the 99th row, how many people will be on the 100th row? Well, it should be, 2 more than the 99th. So A100 is going to be A99 plus 2. And remember, 2 is my common difference. It means that every time the row number goes up by 1, I add 2 more dancers. It's the common distance that gets added each time. So what we can come up with is what's called a recursive formula for the sequence. So to find the nth element, I don't know what n is. It could be 1,000, 10,000, 100,000. To find the nth element, if you knew the one right in front of it, you would just add 2. So the recursive formula for a sequence is to find the nth element, you take the element right in front of it, n minus 1, and you add d, which is the common difference. So if you wanted to find the millionth element of the sequence, you would take the 999 element and add 2 to it. Now this formula is sort of intuitive, but it's really not very useful. Like to find the 1,000th element, you got to know the 999. Well, I mean, if I could find the 999, I would just go ahead and find the 1,000. So it's not extremely useful as a formula, okay? So this is our recursive formula for an arithmetic sequence. A1 is the first element of the sequence. AN is the one right in front of it plus the common difference. So again, so A1, first term of the sequence. The nth term, where n is any number, any integer, positive as I count them, is going to be the n minus 1, the number right in front of it, plus the common difference. So in their thing of dancers, to find how many dancers on the 1,000th row, find out how many are on 999 and add 2. That's all that's saying there, okay? Recursive formula, because recursive means to repeat the process, or the definition is dependent on the one right in front of it, okay? Let's look at this. The first step of a pyramid is 18 inches high. Each subsequent step is 22 inches. Write the recursive formula for this sentence, for this sequence, okay? A1 is the first term of the sequence, and then AN is the one right in front of it, plus the common difference. So A1, this sequence talk about how high each step is. We know the first step is 18 inches high. That means that the nth number is going to be the one right in front of it, plus, now we know after that first step, every other step is what? 22. So there we go. So how would I find A2? So A2 is going to be A1 plus D. So A1 is 18. The common difference is 22. So when you add those together, you get 40. So this tells me that A2 is 40. Then if I look at A3, A3 is going to be A2 plus the common difference. So A2 is 40, so that's 40 plus 22. That's going to be 62. So A3 is 62. A4. A4 is going to be A3 plus 22. So that's 62 plus 22, which is 84. So A4 is 84. So then A100 is going to be A99 plus D, or A99 plus 22. So it's A99 plus 22, okay? Now you can see why this formula is a challenge. It worked well when I was finding 2, 3, and 4, because every time I use the number right in front of it. But then if I look at it, I had a challenge because I don't want to do all the others. But if I look at what was really going on here, A2, I want to rewrite this. So I've got A2. If I look at this, what is A3? So A3 is going to be A2 plus D. So that's going to be A1. Remember that A2 is right here. So this is A1 plus D plus D. So A3 is A1 plus 2D. And then if you think about it, A4 is going to be A1 plus, instead of 2D, 3D, okay? Now, so if you look at this, I can figure out what's going on here. To get the fourth number, I took the first element and I added the common difference 3 times. To get the third number, I took the first number and I added the common difference twice. So to get the 100th number, I'm going to take the first number and I'm going to add that common difference 99 times, okay? So that's how I can figure out, that's the more helpful way of figuring out that element. So what it tells me is we can do an explicit formula. So it doesn't depend on the number right in front of it. So an explicit formula gives me the nth term. So the nth term of any sequence is the first term plus the common difference right here times n minus 1, okay? So that example before, like to find the first element, I was given that one. The second one, the common difference had to be added 1 time. The third element, the common difference had to be added twice. The fourth element, the common difference had to be added 3rd time. That's where this n minus 1 comes from. So let's look at this. The cost of renting a bicycle is given in this table. Create an explicit formula for this sequence. Is this sequence arithmetic? So if you look at the numbers 1, 2, 3, and 4 as I count them, the difference between these two is what? 12. The difference between these two is 12. The difference between these two is 12. So every time I'm going up by the same value. So this is an arithmetic sequence, okay? So it's the same question. In linear terms, we would say, do they have the same slope, okay? It goes up by the same amount every time. So let's find this formula. So we know that A1, this is A1, this is A2, this is A3, and A4. Okay, so actually A1 is this, A2, A3, A4. So the formula for the explicit, AN is going to be equal to A1, that's 26, plus N minus 1, and then the common difference is 12. So we don't usually like to write that D at the end of the term. So algebraically, we would write it like this: 26 plus 12 n minus 1. Now I can leave it like that and work with it, but if I try to keep going, this is AN equals 26 plus 12n minus 12. So AN is 12n plus 14. Now you can check it and see, does that work? According to this formula, A1 would be 12 plus 14, that's 26. A2 would be 24 plus 14, that's 38, okay? Now the other way I can think of this is I can think of slope. The slope of this sequence is 12. So AN is going to be 12n plus some number b that I don't know, okay? Now you know that when you plug in a 1, you need to get a 26. So 26 equals 12 times 1 plus b. So b is equal to 14. So AN is equal to 12n plus 14. So this is the formula. This is my explicit formula right here. But just by distributing, I get something that looks like mx plus b, okay? Let's look at this. What is the common difference? I can look at this and see every time it's going up by 2, okay? Or no, let's see, I thought it was. Let's look at this. So the difference here is 2, the difference here is 4, the difference here is 8. So there is no common difference. So this is not arithmetic, okay? There is no common difference here. So not every sequence is arithmetic, okay? Converting from an explicit formula to a recursive formula. So how do I get here? So here's my explicit formula. AN is equal to 30 minus 4n. So AN is equal to negative 4n plus 30. So when I look at this, that tells me my slope. Okay, slope is really the same concept as common difference here. So in this problem, I know that D is going to equal negative 4. To get the explicit formula, it's going to be what? AN is equal to A1 plus n minus 1 D. So I just need to figure out what is A1. Well, I can use this formula. A1 is going to be 30 minus 4 times 1, which is 26. So the explicit formula is AN equals 26 plus n minus 1 times negative 4. if you're going to work with the formula a lot, it makes sense just to distribute that -4 and combine like terms. So you would get AN is equal to what, -4N, and then I think plus 30, which is what you see right there. Okay. The recursive formula. I know that A1 is 26, then AN is equal to AN minus 1 minus 4. I'm subtracting 4 every time in this particular sequence. So we've been thinking of sequences as numbers that go up, but the numbers could go down. Okay. Convert this from a recursive formula to explicit. Okay. So I've got the recursive formula. A1 is 5. AN is equal to AN minus 1 plus 1/2. So the recursive formula is the number right in front plus D. So I know that D is equal to 1/2. D is 1/2. A1 is equal to 5. So the explicit formula is going to be 5 plus N minus 1 times 1/2. Consider this arithmetic sequence. A1 is 9, AN is N minus 1 plus 7. What's the 50th term? Okay, so what this is telling me, that's the first term. This is telling me that that is my common difference. So the explicit formula would be AN is A1 plus N minus 1 times D. You know that A1 is 9. You know that D is 7. So here's my explicit formula. So the 50th term, A50, is going to be 9 plus 50 minus 1 times 7, which is 9 plus 49 times 7. So 49 times 7 is 343. So this is 9 plus 343, which is 352. The third term of an arithmetic sequence is 5, and the sixth term is minus 1. What is the 20th term? Okay, so the third term is 5. The sixth term is -1. What is the 20th term? So I know that the third term is going to be the first term plus 3 minus 1 D, right? I know that the sixth term is the first term plus 6 minus 1 D. Okay. So what I've got to figure out here is how can I figure out what D is, what the first term is, okay? So if I go from the third to the sixth term, so A3, A4, A5, A6, okay? So if I knew what the third term was, I have to add D to get this one, add D to get this one, so add D to get this one, okay? So what it means is if you're adding 3D, okay, to get to the sixth term. So what it means is you know the third term is 5. So A3 plus 3D is going to give me A6, right? So A3 is 5 plus 3D equals -1. This means that 3D equals -6, so D is equal to -2. So I know my common difference is -2. So this formula is going to be what? AN is equal to A1 plus n minus 1 times negative 2. Now I know the D, but I don't know A1 at this point. So how could I figure out A1? Well, just use what you know. You know that A3 is 5. So that means that 5 is equal to A1 plus, and so this is A3. So 3 minus 1, negative 2. So 5 is A1 plus 2 times negative 2, that's negative 4. 9 is equal to A1. So all this, and I now know my formula is AN is equal to 9 plus n minus 1 times negative 2. So A20 is 9 plus 20 minus 1 times negative 2. So that's 9 minus 38, which is what, negative 29. What is the 171st odd positive integer minus the 199th even positive integer? Okay, so let's look at this. Odd positive integers, what do they look like? 1, 3, 5, 7, 9. Okay, that's an arithmetic sequence. So these are the odds. Well, this has a common difference of 2. So AN is equal to 1 plus n minus 1 times 2. That's what this sequence is. Let's look at the evens. The evens are what? 2, 4, 6, and so forth. Same common difference, but here AN is equal to 2 plus n minus 1 times 2. The 171st odd is going to be A171 equals 1 plus 170 times 2. So that's going to be 341. The 199th even, A199, is equal to 2 plus 198 times 2. So that's 398. This is 398. So what is the odd one minus the even? That's 341 minus 398, which is negative 55. For an arithmetic sequence, A1 is negative 5. If A5 plus A10 plus A15 is 66, then for what value of n does AN equal 172? Now these, your head spins, but you just write down what you know. A1 is negative 5, okay? A5 is going to be A1 plus 4 times the common difference. A10 is going to be A1 plus 9 times the common difference. A15 is A1 plus 14 times the common difference. Now, what do you know about all three of these guys? I know that they add up to, what, 66? So this is 3A1 plus, what is this, 27D. But I know A1, right? So I can substitute that in. So 66 equals 3 times negative 5 plus 27D. So that's negative 15. If I add this over to the other side, you get 81 equals 27D, so D is equal to 3. So now I know, if I look at my formula, in order to use this formula, I need to know this and this, okay? Well, I know A1 is negative 5, so AN is negative 5 plus N minus 1 times 3, okay? For what value of N does AN equal 172? So 172 equals negative 5 plus N minus 1 times 3. So 175 equals 3 N minus 1. Divide by 3. Wait, did I do that right? No, sorry. When I added the 5, this is a 177. 177, divide that by 3. 3 goes into there 5 times, so 59 is N minus 1, so N is 60. That's it. So this tells me that A60 equals 172. So again, I was solving for them. Normally I'm solving for A sub N, but here they gave me AN, and they wanted me to figure out what N was. So that's sort of the trick. Sometimes you'll be solving for a different thing in these problems. That should take us up into the homework for this section.